Alright, welcome to today's lesson on arrays. So in order to know what an array is, we have to first go back and ask ourselves what a variable is. And a variable is basically a symbolic name for a location in memory that we're going to use to store data. So when I have something called int age, I'm basically setting up a location in memory that's going to hold an integer value that I'm going to use to represent somebody's age. And I can call that location in memory age, and every time I refer to it, I'm referring to that piece of integer data that I'm working with. Now an array is basically the same thing, but now instead of storing one piece of information, I can store a set of pieces of information, all of the same type, all under one name. So I can access all that information just by using one variable name. An example we have here, again, instead of having one student age, I'm going to have multiple student ages, and I do this by having an integer array. So I've set up a location in memory that is going to store a whole bunch of pieces of information of the same type. So why would I want to do this? Well, number one, I can have a large amount of data stored in one location. I can reference it by talking about one variable. Even though I do that, I can still access the individual elements one at a time, and I can also do operations on the entire data set very simply by using simple looping structures. Now there's a couple of things we need to remember when we're working with arrays. The first is that when we're talking about an item in an array, we have to talk about the name of the array and its position or index within the array. And when we talk about an element's index or position, we have to talk about numbering from the position 0. So just like we talk about when we're talking about a character position in a string, we have to do the same thing here where we start numbering it at 0. So the first element will be position 0. Items in an array can be of any of Java's primitive data types. So we can have an array of integer values, an array of doubles, an array of characters, and so on. We can also make an array of any object that we wish. So we can have an array of strings, an array of robots, or an array of any other class that you want to create. The catch is that all the elements in your array must be of the same data type. You cannot have an array that has multiple data types being stored in it at the same time. And in addition, an array's length must stay static throughout its entire existence. So once I have an array of a certain number of elements, I can't make it any larger or smaller. It will always be that size. So in order to use an array, you have to follow 3 steps. The first thing you have to do is tell Java that you're going to have an array. You create the array. This is called the array declaration. You then set aside a certain amount of memory that is going to be able to be used to store all of the data that you're going to require in your array. This is called memory allocation. And then finally, you want to give each element in your array a value. This is called array initialization. So we'll start with array declaration. When you declare an array, you do it the same way you declare any other type of variable. You write the type of variable it's going to be, the type of data it's going to store, and the name for the variable. The only difference is you have to add these square brackets beside the word int to reference the fact that you're going to be storing a whole bunch of data of this type with this particular name. Next, you want to allocate the memory. When you do this in the similar way that you would do to construct any other type of object by saying your array is going to be equal a new integer array or a new double array, a new robot array, whatever. And then inside these square brackets, this is where it's a little bit different from a constructor, you use square brackets here, and here you put in the number of elements you're going to have. So at this point in time, the Java virtual machine will allocate enough memory to store 12, in this case, 12 elements of this type of data. Okay? And you don't have to use a hard-coded number in here. You can have any variable in here as well, as long as it evaluates back to an integer value. If you know how many elements you want to have when you're creating or declaring that particular array, you can combine the first 2 steps by doing something like this. So integer array student ages equals a new integer array of size 4. This would create an array like this. So I've got my variable here that's referring to this location in memory, and I've got 4 values starting from particular position 0 to position 3, and right now it has no values in it. So next I want to actually initialize the values and give them some data inside them. I do this just by saying the name of the array, the position or index I'm working with, and then what I want its value to be. So if I run these 4 lines of code, I'd end up with an array that has these contents in it. Again, we can combine all these steps together into one big step by using what's called an initializer list. So when I declare my array and I allocate its memory, instead of providing a value inside the square brackets, I can use squiggly brackets and actually provide the specific pieces of data I want. This will create an array of the exact number of elements in size and put the data in it automatically. So this particular example here would have an array of strings where there'd be a size of 2, and this integer array would have 4 things in it. Now, if you want to access individual elements out of the array, you have to do so by talking about the name of the array and the position of the piece of data you're looking for. Again, that's called its index. The array index must always be an integer value. So, for example, if I'm looking for student ages 5, this is going to give me the 6th element of student ages. Remember, we're starting at position 0. So 0, 1, 2, 3, 4, 5. That gives you 6 elements in total. So what position would this be? Which element would this be that I would get? And hopefully you got the I plus 1th element of the array. What about this? Now you can see this is a little bit ridiculous, but it would give you the 10 times I plus j plus 1th element. And then finally, what happens if I try and get this element? Well, this is going to give you an error because you can't have a position that is a negative value. So all your values start at 0 and go upwards from there. So now let's assume I have the array depicted here. What would the code in these 2 lines return or print to the screen? They would print 6. Why? Because I'm having x equal to 2 plus the value of what is in array position 3. So I find array position 3, it's containing a 4. 4 plus 2 gives me 6. And now if I add in these 2 lines of code, I would get the value of 50. Again, why? So array at position x. Position x, x is 6, so position x is 45. I'm going to add to that the value of array 7, which is 10, divided by 2. So 10 divided by 2 is 5. 5 plus 45 gives me 50. A 50 gets stored here. So now this integer value would be replaced with the number 50. So when I print it, I'm going to output the number 50. And I've also modified this particular data piece in my array. Now if I want to access all elements as in an array, as I said before, you can do this using a simple loop. So you do this by saying I'm going to start at position 0, go up 2, but not including the length of my array, increasing by 1 each time, and then I can do whatever it is I need to do inside to each individual element. So element 0, element 1, element 2, and so on. The one thing you need to notice here is, unlike using a string length, this is not a method of the array class. Length is not a method in an array. This is a property of the array. So I don't need to put smooth brackets beside here because I'm not running a method called length. I'm running or accessing the information or attribute of the array, which is the number of elements that are in it. Now sometimes it's going to be frequent for us to use multiple arrays in a program, specifically trying to copy data from one array to another array, and this can often lead to errors or unexpected results if you don't do it properly. What a lot of people tend to do, and this is a mistake, is they tend to say array 1 equals array 2, thinking that this would put all the contents here inside here. But it doesn't really do that, because these are just pointing to a particular array. They don't contain all the data themselves. They just point to the data sets. So as a result of doing this, I end up having the content of array 2 being pointed to by array 1. So they're both pointing to the same set of data. This means that whatever array values were pointing to from array 1 are now lost. They're no longer existing anymore. They're gone. They've been replaced by pointing to the same data that's stored here. This means that if I change the values in any of the elements in array 2, I'm also changing the same values in array 1 because they're both pointing to the same set of data. But if I actually want to have a copy of it, instead of having them both point to the same piece of data, if I want to have 2 copies of the same data so that if I change one, I'm not affecting what's in the other, I have to do this using a loop. And then I have to individually copy the data in one element to the next element. So in this case, I'm going to go back to that same loop where I cycle through every particular element in my array, and I copy all the pieces one at a time from this array to this array. And that now gives me 2 arrays pointing to 2 different sets of data that happen to have the same values in them. So if I change the data here, it doesn't affect what's in here. That's it. That's all we have for today. We'll see you in class tomorrow where we can practice what we've learned.